All right, hello people watching this video. We are doing the last two examples on the 10-1 notes, which is the law of cosines. Okay, so yesterday we got through like example 2, I think.
Yeah.
All the way through here. Okay, these are the story problems. There is no diagram for example 3, so we got to draw a picture. Here we go. Two trains leave a station on different tracks. I'm going to start my station down here. We're going this direction, and they're making a 125-degree angle, which I'm going to say looks-ish like that. This is 125 degrees, is them going, right? Okay, so put this on your notes. Go, get it out. Here we go. 125 degrees is the vertex where they split each other. The first train travels at a speed of 100 kilometers per hour. The second one's going 65 kilometers per hour. So I'm going to say 100 kilometers per hour and 65 kilometers per hour, but we're going to change those labels here in a second because it says how far apart are they after? 2 hours. So that's not 100. That is now 200 kilometers, and this is now 130. Okay, so they're going that speed for 2 hours. Okay, how far apart are the trains? They want to know this distance right here. Okay, that's fun. Now, do we use the law of sines or the law of cosines?
I'm gonna say cosines.
Okay, like just look what we have. So we have a side here, we have a side here, and the third side we're looking for. So we have 3 sides and how many angles? One angle. Okay, 3 sides, 1 angle means the law of cosines. If we have 2 and 2, that's when we do sine of A over A, sine of B over B, right? Yeah. That is 2 angles, 2 sides, right? Mm-hmm. So I have to do the law of cosines here instead of the law of sines, right? Mm-hmm. So I'm going to call this guy x, and we're going to put him in this spot, x squared. Okay, and if I do that, then cosine of the opposite angle has to go over here, 125. Yeah? Mm-hmm. Okay, make sure that your calculator's in degrees. We're going to do 200 squared plus 130 squared minus 2 times 200 times 130 cosine of 125. You should be able to just type that whole thing into your calculator and get x squared equals something and then take the square root. This is kind of a quick one.
Or you can just square root it up.
Or you can just square it at the beginning if you want to. Yeah, the square root of all of that junk, right?
You're so smart.
Don't complain too much, or you will get too big.
294.5.
What?
Wait, what did I do?
What did you say? 290 what?
I got
294.
244?
294.
I got 294.
294.5.
At the end, after you square it?
Mm-hmm.
Yeah.
294.5?
Yeah.
Oh, that's probably why. Yeah, forgot a 0.
294.5, and that's kilometers, right?
Yep.
Okay, would it make sense for that to be 294.5 kilometers?
Yeah.
Okay, that's going to be the biggest side, right? 200 and 130 in the opposite directions, kind of opposite directions, so 294.5, that sounds reasonable. Yeah? I almost like the story problems better than I do the other ones because we only have to solve for one thing, right? Like you're only solving for one side, now we don't have to keep going, right? So even though they don't give us the diagram to begin with, yeah, that kind of sucks, but like now they give us, you know, something easier. This story problem I'm not going to like because we got to do a bunch of stuff, okay?
Oh my goodness.
And they do give us a diagram. I have no idea what the approach is on this. We're going to see together what we can do, so help me out here. They say a 100-foot tall antenna tower, that's this guy, this is 100 foot. Is placed on a hillside that makes a 12-degree angle of elevation. So like this is 12 degrees. Now, this right here, this little bottom sliver is making a right triangle. So I'm wondering maybe if we use SOHCAHTOA at some point, right? Because that's a right angle. Like just with this little triangle right here, maybe we use SOHCAHTOA to solve for something. I'm not sure. I don't know. We'll see, okay? It is to be anchored by 2 cables from the top tower to points 85 feet uphill and 95 feet downhill from the base. So this distance is 95, this distance is 85. How much cable is needed? Okay, so where are our cables located? B is a cable and K is a cable. So total cable is the first cable plus the second cable. So we're going to find out those 2 lengths, okay? All right, so, yeah. All right. Interesting. Interesting. Okay, all right, okay, I got it, I think, maybe.
Did you try to draw?
Let's solve for B, okay? I'm looking at just at this triangle right here, squared, solving for B. We have that this side is 95, this side is 100, and we have B there, but we need an angle. Do we know any angle things?
Just 12.
We just know 12 down here, right? Okay. Can I use that to like solve for this guy right here?
Yes.
Yeah.
If this is,
If that's
I don't think you even need
78.
to do anything, right? If
They
this is
have to
12,
add
what's this guy right here?
102.
78.
This guy is 78.
78.
So the other
Right.
one's 102.
Do you see how we get 78 out of that? And that's a
Yeah.
right triangle? No. Okay. So this little guy right here is a right triangle.
I did
Right?
that
If this
differently.
is
I
90
want
and
a whole
that's 12,
different
this is 78.
Okay.
Yeah.
Mhm.
Then this guy would have to be how big?
102.
102.
And the angle B
That one
is
has to be
78.
180?
So 102. Yes, inside of this little triangle is
And
right.
on the other side,
Angle B is 102.
Angle B is 78 as well, right? Because those are vertical angles across from each other. Okay, so we've got that going on. All right, so now I can do the law of cosines again. We've got B, which is over here by himself. We're solving for B. We've got 95 squared plus 100 squared minus 2, 95, 100, cosine of 102. And you should just be able to type that all in at one shot and take the square root and do all that stuff. And we will solve for B. One side of my cable is how big? It has got to be probably bigger than 100, right?
151.6.
One fifty one point
The
six.
same thing, and I didn't have to
Hey.
use that.
You didn't have to use that.
No.
No way.
No, look.
What'd you do? I know what you did. You found
Find that
this,
one and
and
that
then
one.
you did a SOHCAHTOA thing. Ha! This is brilliant. Okay,
good.
but you had to do it twice, right? But it
That
still
was
probably
really-
was maybe faster than.
Yeah.
So this is what Libby did. She used SOHCAHTOA to find this length right here, added that to 100 to make this length, and then used SOHCAHTOA again to find B. Does that make sense? So she did two SOHCAHTOAs, right, to find
She's
this B
smart,
length.
I
Does that make
know.
sense?
I don't know
That
how
would
to
work
do
too.
that one.
Sure, why not? Yeah, that would work. Okay, so 151.6, that's this side right here. Now let's talk about how to solve for K. So the other things that I'm going to use to solve for K are 100, 85, and 78 degrees. So if K goes here, then cosine of 78 would have to go here.
Yep.
And 100, 85,
5 squared
minus 2,
times
185.
85.
Cosine of 78, there he is. K equals however much.
The square root
Bigger than 100, but probably smaller than 151. Bigger than 100, but smaller than 151. I'm guessing.
I got 114.8.
That sounds appropriate.
Alright.
Let's make sure somebody else got that. 114.8.
Why I order?
114.8 maybe? Any other takers?
That looks right.
That's not what Libby got though.
I'm also like typing things wrong.
Anyone else?
Good enough.
Libby got 117.0.
I'm still getting that.
What?
Let's think here.
Libby got 117.0. Any of those?
I don't know, I'm not getting the same thing.
Here's my deciding factor.
Oh, I'll do it. I don't know how
Take
to
the square root of all this junk.
100 squared. Square root of 85.
I got 117.
117.0. Okay. So you must have just typed the number wrong.
Maybe. I've gone it 3 times.
So they're wanting total cable. How did I find
Oh,
total
I did do
cable?
117, never
Okay,
mind.
perfect.
I
did
did
too.
something.
Total
How
cable?
many fingers am I holding up?
can see it's 1. 2.
Add them together.
268.6.
How many fingers
268.6.
am I holding?
Perfect. And that is in feet.
Okay.
I can see
like,
the image.
There we go. Hey, that wasn't too bad. That's just two, like, it looks like an icky diagram, but that wasn't really that bad. I don't think, anyway. Right?
No.
Okay. On your homework assignment, everybody listen to this. Number 4.
It's weird.
Number 4 is weird.
It's a little crazy.
Number 4, I'm going to erase what I have because I probably don't have it right. So number 4,
Claire, what does
1,
this say?
2, and 3 are just fine. Angle 1, 2, and, or number 1, 2, and 3 are just fine. But number 4, are you guys listening?
Yeah.
Number 4, Jalen did it and then she got something that was kind of weird. And then Libby did it and she kind of got the same thing that was kind of weird, but they were the same kind of answer, whatever. Number 4, I think, is one of those triangles that has 2 different solutions. right? You know how like we talked about you have two different solutions? So if you're getting like different values for angle A and angle B, just know that there's two different possibilities for setting up this triangle. And so that's the thing. So if your answer is not the same as somebody else's, it's because you found the other triangle and they found the one triangle, okay? And it has to do with the fact that when you're doing this, if you solve for angle A first, you will get one of the triangles. If you solve for angle B first, you'll get the other triangle, right? And they both are okay. They're both they both are solutions, but just know that I will accept both answers, okay? You don't have to find both of them, but I will accept both answers. Does that make sense? Okay, so that is one of the weird ones where there are two different solutions and they both are okay, okay? Got it? Okay, sure, if you want to turn it in, that's fine. If you are done. Perfect. All right, bye people watching the video.